This question shows a function and asks us to estimate the intervals of increase and decrease. So the best way, I think, to think about increase and decrease with functions is to pretend that the function is a grassy hill. And here you are walking along the function. So there are places on the curve that could be considered peaks and places that would be considered valleys. The very top of a mountain would be considered a peak, and the lowest point on the curve I would call a valley. In math, the peaks have a technical term called local max, and the valleys are called local mins. It's good to identify the peaks and valleys because when we talk about intervals of increase, we're going from a low point to high. And when we're talking about an interval of decrease, we're going from a high point to a low point. We always want to think about the person traveling to the right in math because the right is the positive x direction. So as our person walks, we see that they would be going from a peak to a valley in this middle section, and that would be called an interval of decrease because they're going from high to low. When the person is rising in elevation, though, that would be an interval of increase. So on one side of the peak, you have an interval of increase. And on the other side of the peak, you have to have an interval of decrease. Because it wouldn't be a peak if you didn't have that. You have to be having the graph sloped up to get to the peak, and then sloped down after the peak. That's what makes it a peak. So on the left side of the valley, our guy is decreasing, but on the right side of the valley, the guy is now rising in elevation, so this would be an interval of increase. Now our job is going to be to put these intervals into interval notation. First, we want to find the x values of where the peaks and valleys are. So on this axis, the peak is hovering above an x of -6. And I'm just reading that off the horizontal axis here. So there's -5, there's -6, there's -7. The valley here is hovering below an x of +6. I can just read that off the graph here and just trace it down, and that's the x location of the valley. We have to know the x values of where our decreasing interval starts and stops so that we can say the person is decreasing from x equals -6 to x equals 6. When you give intervals of increase and decrease, you only give the x values, not the y. So that can answer this question here of where is the function decreasing. But now to put that more into symbolic form, we could write it like this, that we're decreasing between an x of -6 and an x of 6. So anywhere between -6 and 6, these are locations where our graph is decreasing. This is called algebraic form when you write it like this. But the problem asks for interval notation. So for interval notation, we want to use parentheses and a comma. And we have to put the starting x on the left and the ending x on the right. So the starting x for our interval will be -6, and the ending x will be +6. So this and this and this all say the same thing. The answer that the question wants is this. Now let's give the intervals of increase. I think the easier of the two is this one on the right. So when our guy is located at the valley, he's located at an x value of 6. And we have to say now, at what x does the increase stop? So just from this picture, we don't see any evidence to suggest that the increase is ever going to stop. And if we want, we could take a look at this graph in Desmos and try to confirm that. Here is the graph. And as we go out to an x of 20, and an x of 30, and an x of 40 and 50 and 60, the increasing never seems to stop. You might argue that as you go way out, the slope of it becomes smaller and smaller, where it seems to level off. But even out here at 320, here we see that the function's value is -0.2. And now we'll go some more to the right and see if that changes. Let's go to 380. At 380, the value is less negative than it was before. So really, the thing is still sloped up. In fact, this upward slope will never stop. The slope will get less steep, but it's still going to be an increasing slope. So generally, when you see graphs like this, you just assume that the trend continues unless there's reason to doubt that. So my guess is that this is going to be increasing from an x of 6 to an x of infinity. Now for the left side here, we see that our guy is walking uphill, and it's like, when did he start walking uphill? Well, all the way to the left is when he started that. So I'm going to say that he's also increasing in elevation from the very farthest left that you can go, from an x of -infinity to an x of -6. So in order to state both of these intervals, one of them is from -infinity to -6, and the other is from 6 to infinity. If the question asks for a list of intervals, you could put a comma between them. Sometimes the question, though, wants a union between the intervals. So I'm just going to make a list of the intervals. The next question asks us to give the local maximums as coordinate pairs if they exist. I already determined that there was a peak or a local max, and so I just need the coordinates of that very highest point on the graph. In the Desmos program here, we can actually click on the peak, and it tells us that the x location of it is at -6 and his y elevation is 5.33. So the coordinates are -6, 5.333 for that local max. And for the local min here, the valley, we see that he's located at an x of 6 and a y of -5.333. The last question here is to find the range of the function. So the range is going to be all the y values of the graph. If we look at the graph, we see that the lowest elevation here happens to be negative 5.333. That's here on the y-axis. The highest point occurs at positive 5.33. I'm giving y values here, not x, because range is concerned with y. So we just need to say that the range is from a lowest elevation of negative 5.3 to the highest elevation of 5.3. And so this yellow interval here represents what is called the range of the graph. We can put it into algebraic notation like this. But this question wants us to give the range as a lowest value, comma, a highest value in square brackets. The reason square brackets are used in this question is because that point really does touch a y value of negative 5 1/3. It doesn't just approach the value, it really holds that value. It would be negative 16/3 as a fraction here, and this one up here would be positive 16/3.